Have you ever wondered where some of our everyday plastic products come from? Would you believe that a plastic bag and a table are made from a similar process? The guys at Glycon and Tecumseh know how. What did they make at Glycon? Find out today on Made in Lenawee.
People hear that they work in a machine shop or something like that. They don't really understand, and people that actually get to come through our shop and see the types of parts that we manufacture get a new appreciation for exactly what goes into manufacturing one of these pieces.
It's crazy because, they're from like 10 pounds all the way up to 5,000.
Metal feed screws for plastic injection blow molds. These variable size screws mix and melt plastic pellets to the right temperature, color, and consistency to make a variety of plastic products. Before we can understand how they are made, we need to start with how Glycon became a leader in manufacturing in Lenawee County. Jeff Kumin played at the University of Vermont and is a Hall of Fame tight end there. Drafted in the 15th round in 1968 by the Denver Broncos, he played with their taxi squad in Seattle before joining the Cleveland Browns, affiliated in New Jersey the next year. It was there he found his way to a company that manufactured feed screws.
Well, it actually started, I worked with a company that was based in New Jersey, and that company was in the plastics machinery industry, so that the knowledge of the product that we manufacture came from the experience I had during the off seasons from playing football. That was a spin-off from the company that I worked for in New Jersey, and was eventually acquired by a Michigan company that was called Hoover Ball and Bearing at the time, and it's now Uniloy, located also here in Tecumseh. I'm the happiest because we just love it here, and the way that we ended up here, when I was involved with that company in New Jersey, and Uniloy bought us out here, my wife, who's from Vermont, actually selected Tecumseh because it reminded her of her hometown in about the same size in Springfield, Vermont, and she loved Tecumseh, and she made a good choice.
After finishing his 5-year term with Uniloy, Kumin branched off to become a manufacturer's representative, selling feed screws and component parts. It didn't take long for him to realize that if you want to do something right, you got to do it yourself. So the idea for Glycon was born.
So it was an evolution. The first thing that we did, the first piece of capital equipment that we bought was a truck, because those people prior to that were shipping their screws all over the country, and a lot of the lead time in getting the repair work done on the screws and barrels and non-return valves, which was what our product line was. It was a step-by-step process, and as you can see in some of the pictures around here, we were actually located when we were manufacturers' representatives, we were located in a small building because it really was building blocks. We started with one building, which is directly across the street here on Russell Road, and we doubled the size of that building, and that was the front of it was office space, and then the back became, an inspection area, and if there was any minor work that needed to be done on screws, we did it here. Screws were still manufactured at the facility in Windsor, but then we bought the building next door to us, and we doubled the size and then tripled the size of that, and we moved some lathes in, we moved some milling machines in, we moved some welding operations in, and then we were in it for the long haul at that point. We invested in a plant in Canada that was manufacturing, Windsor, that was manufacturing feed screws, and eventually ended up buying that plant and moved some of that equipment down here, and that's how we got into actually manufacturing the feed screws. And that's when this industrial park at the time was empty. There were no buildings in it, so we were one of the first people to buy, and we bought this corner, which is actually 5 acres, so we've got a lot of area to expand in the future, which we've already done, one significant expansion, and then we built our product development center in the facility next door. So it was definitely a building block process and a growing process through the years.
So one of the things that's changed in the time that I've been here is that we've gone from probably being maybe 65 to 70% automotive supply base to switching that down to probably about 30-35%, and now we provide products to a lot more of a diverse background in terms of customers.
And it's given us a great opportunity, not just in the feed screws and the primary product that we manufacture here, but some of the complementary products that we've developed to market in, things like what is known as a feed throat and tie bars that go onto the presses for the machine, which those kinds of things lend themselves well to the equipment that we've got here. So
would be considered packaging, and that envelops a broad range of different types of products, from store shelf items to plastic bags, things that you find in Walmart and things that we have major customers that deal in those type of products.
It's pretty cool. Like every time I walk into Walmart, I think about, you know, my screws make all those bags. It's pretty cool. Like if it wasn't for us, like everything plastic would, I mean, it'd cease to exist.
Josh is one of several Glycon employees that came through one of the LAC Tech Center programs. A number of them have great stories overcoming adversity just to begin their careers, like Josh Duff, a 14-year member of the team here.
The top people that we've got out there, we have you know, one fellow who we call our poster child, you know, and that's just a rags to riches success story. You know, he had some issues in his life, some difficult times in his life, and came through here with a group of students and said, this is what I want to do, and the rest is history.
Well, it was set up through the Tech Center. We took a tour through the shop, and I really liked what we were doing here, and we set up an interview, came and seen them, and then I started working here through the summer. You
know, he was a co-op student his senior year. His grades improved dramatically.
I would go to school for 3 hours, and then they allowed me to come here and work for 8.
He's been with us ever since, and I think he's going on his 14th year, and he's arguably the most talented guy in our shop. Does a great job for us. Just a very skilled guy, just you know, and great lifestyle, and he'd get embarrassed and denied if I said that. Got a beautiful home on the lake, out on Devil's Lake, and you know, got a ski boat and a truck and a car, and no payments on anything. So, you know, that is just a great testimony to the kind of future that is available in manufacturing. That's the most important thing now, and that's the thing that's hardest to find, is that, you know, people don't see that as a positive career, and he did. And so that he worked that particular summer, and he's a good person.
Yeah, I think the Tech Center gave me the building blocks to do what I'm doing now. They gave me the tools to know what I was getting into, knowing how to use precise instruments, so I wasn't just coming onto the job blind. I think it's a great thing to get that experience.
What we find is the people that we work through that have gone through the Tech Center, the interesting thing is it's not necessarily all from the machine trades. We've had a lot of success with people that went through the Tech Center, that went through some of the other programs. And one thing that we've always appreciated from the guys that we've hired through an association with the Tech Center, or that had previously they had association with the Tech Center, is that they come in with a good work ethic. They've been put through the ropes, so to speak, in learning a trade. So they know what goes into it. They know the type of attention that they need to pay and the type of effort that they put into it. Not all of them came from the machine trades. We've got a couple of people that came from building trades and things like that found their niche here and have really fit in and done a nice job for us.
Well, Mr. LaFollette also always stressed on just, you know, working hard. That's just always what I've, you know, known how to do. Just, you know, I've worked my butt off for everything I got, so.
It just shows you that if you've got a motivation, if you're driven yourself and you want to do a good job and you want to make a career for yourself, there's an opportunity out there. You run into so many times that people want to, you know, come in and just kind of punch a clock.
And desire and dependability. If somebody's here and they want this and they're looking for a career, we've found that you can train just about any of the people that have the right attitude. A lot of negativity associated with careers in manufacturing now, and we really, more than anything else, want to destroy that myth, because we'd like to bring young people in and see them develop their futures here.
Well, I've been working since I was 14. I bought my first truck when I was 16, and I'm 20 now, and I own my own house and a brand new truck, so I feel like I'm doing pretty good. Just get after it, I guess.
You know, and a lot of the people don't get that opportunity. That's one of the nice things about the Tech Center, is the fact that people just don't get an opportunity to try things and to see what it is that would be the best vocation for them. This one happened kind of naturally, and it was a great idea that Jim brought his class through here because people could look at it.
It's just a laid-back place to work. I mean, you're expected to get things done. As long as you get them done, nobody's harping on you, so.
We gotta work as a team. And if we don't, you know, somebody slacks in one area, eventually it catches up, you know, down the line. If somebody skips, you know, on a part when we first start off, you know, it's gonna be messed up at the end. So, I mean, if we don't all work together, if something happens at, you know, one stage of the process, and everybody's just gotta help, you know, along the line.
That team effort comes together to manufacture this, a feed screw, ranging in length from a foot to 16 feet, with diameters between 1 and 8 or more inches. There are a variety of designs for these screws, matching the volatile needs of the plastic industry.
The resins and the plastics are changing constantly for the design for different properties. And whenever there's an engineering change that's done on the plastic side that affects the pellet, that also affects the melting characteristics of that pellet, then there's going to have to be some changes made in the design. So while there may only be 3 or 4, say, general groups or families of screw design, within those there are probably an infinite number of subgroups that are designed to interact with specific grades of plastic.
I never cease to be amazed by that bar of steel that comes in here, and I see the truck comes in every day now. That, you know, we're fortunate, we're blessed, we've got a lot of business right now, and I always look at the guy and say, he must get tired of coming in here every day and bringing the steel in. But it's really nice to see, because you see the entire process. You see, in the same day, you see the steel truck coming in the morning, and at night you see 2 or 3 or 4 different trucks going in here with finished product that's leaving here, that's going all over the United States, all over North America.
What happens is the screw works as a conveying mechanism, so it's being turned and it's forcing the plastic to go downstream towards the mold. What happens is that the way that the screw is designed, the geometry forces the pellets to be pushed up into the barrel wall, which creates friction, and also the geometry of the screw will either create friction or try to manage the friction that's going into these pellets. So what happens is that as it travels down the length of the screw in this barrel, it'll go through various stages of melt, and the end result is at the end, when it's getting down to the very end of the barrel, it should be melted with all the color mixed into it if it has a color additive to it. And there should be no unmelt or any impurities left in the plastic at that point. At the end of the day, there's lots of different types of plastics that go into different things. What may go in a instrument panel for a car is a different type of plastic that you'll be processing for making bags for Walmart. So each of those different types of plastics have different types of processing characteristics.
The corkscrew style, you got ones that look like a pineapple when you're looking at it, the skin on a pineapple. It's a mixing section. We've done all kinds of weird designs over the years that people thought would work.
So how does it really get from this, a rusted hunk of metal, to this, a finished product ready to make a number of products we use daily? As you might imagine, there are many steps to this process.
They come in all rusty and stuff. They just look like they came out of a cast, pretty much.
So you've got a lathe operation in which you're turning that down to a precise bar, because it's just a rough piece of steel when it comes in here.
And so we have to turn them down so they're more round, because they come in and they look like eggs. They're not round at all.
And once it's been turned to a particular size, it will go into one of our milling machines. And at that point, what we do is a process called channeling. And essentially what that does is that lays a deep channel all the way down the outside diameter of that bar of steel. So you'll have something that looks like a river channel, or whatever you would want to think in terms of a channel that goes down the entire length of that screw in a spiral fashion.
The screw actually spins, the parts you're machining. It turns, your cutter spins, and then it follows a lead and it makes like a corkscrew style.
And we put hard-facing alloys and fill these channels, and that becomes the top of the flights on the screw. And the reason that you do that is that when this goes into operation in melting plastics, that's a very hostile environment, very abrasive environment. And if you didn't put carbide alloys on the surface of the flights, these things would wear out in a couple of weeks.
It's like, I mean, it's really hard stuff. We can't machine them. Like once it's welded, we have to grind it down because it'll just break cutters.
So what happens at that point is it'll go into the welder, it'll be welded, it then goes into a tank of vermiculite, which will slow cool the screw. At that point, it may stay in there for 2 or 3 days depending on how big the screw is, and the process there needs to slow cool because the weld that is put into the channel has a different rate of cooling than the base steel.
The weld is all uneven, and they have to fit inside of a barrel, which it can only be off like by hairs. So like about 5 hairs on your head. I mean, and we're talking the weld when it comes out of the welder is, you know, it could be off 1/4 inch. So we throw them in the OD grinders. OD is for the outer diameter of the screw. And we have certain tolerances that we have to take the OD down to.
Once the hard facing is welded on it, then we actually cut away the steel that becomes the channels of the screw. And that's done on a very, very sophisticated machine, and we are the first people in North America to have purchased a machine that actually is what they call a dual slide machine. It was manufactured in Austria, and it does both the milling function and what they call whirling. You actually have 2 different slides, and you park one slide, and so you're either milling or that you're whirling. And that's how you remove the metal and create the channels in the screw.
Milling, whirling, and other parts of this refining process generate a lot of dust and particles in the air. Glycon has been working to continually improve the air quality and the overall working environment in their plant.
We've done, you know, and we're very conscious of our environment here. You know, we've done things to improve the environment. You know, we painted the floors in a light color. We put all new lighting in. We moved all of the dust in the particle generating operations into a segregated area and put dust removing systems in, state-of-the-art dust removing systems in, so that people are spending their time in a nice environment. But the reason that we built that addition is that we had bought this $2 million machine from Austria to cut the screws, and even to have somebody to come over here to service that, it's about $20,000 to have somebody come over and do the regular service. And then we also thought about, as I mentioned earlier, about the environment for our people in there. If you had all this dirt and dust and it was messing up the CNC controls, then it certainly isn't very good for your lungs either. And so that's when we put this addition on the building, and at the same time you take an area like that, which is much smaller than the large area that we had in our plant, and it's a lot easier to get those dust and smoke and all of the foreign materials we've got in there. And if you go into that area in the plant, you know, you look around and it's just as cleaner than it is in the main area of the plant. So we did a great job with that.
At that point, it will come out of the CNC machine. It'll go over to one of our belt polishing stations, which looks like a big belt sander. It'll start at a heavy grit and go down to a finer grit through that process. What we're trying to do is take all the imperfections out of the bar of steel at that point. One of the things that plastics hate is anything that's a rough surface, so that it'll want to stick to and then degrade. So we get a very fine polish on that, on the screw at that point. Probably 95% of our screws are chrome plated, so that's the polishing process that happens right up until the chrome plating. When it comes back from the chrome plater, we will buff it and final polish it. We will also put the drive end on the screw. There are various different milling operations that go into the fit and finish for the actual machine that it will be going into.
At that point in the game, the part is very expensive. It's had a lot of outsourced operations done to it also, with the plating or carbide, nitriding, stuff like that. So to scrap a part out at that point is very costly. Usually the final lathe guy is responsible for finishing up overall lengths, tight tolerance areas, grooves, internal threads, like I said, external threading. A lot of the feed screws have valves that are screwed onto the front. That's where the external threads will meet the internal.
You have to bore out a hole, and then you have a sharp tool that looks like the end of a knife that has to go in and out every time the same way. And if anything moves, you'll cross thread it, and it's a bad deal. And the machine travels like you have in and out, but the machine coasts, and you only have like less than a 1/4 inch to stop it in, and if you don't, it'll smash into the back of the hole and break the cutter, and it's just a bad deal.
It's a little complicated because you're working blind and you have to really rely on your program because it's very easy to crash the tool. So you need to make sure that your program is correct, and you do that by rendering the part. And so it's a lot of trial and error. You need to be very precise with how you've programmed the part, obviously.
Whatever you tell it to do, it's gonna do. But you just gotta make sure that you have everything programmed right and that the screw is held in there right, because I mean, there's different kinds of clamps and stuff that we use to hold the screws in, and if it's off a little bit, if it starts to wobble or anything, it can go real bad. I mean, you can throw a screw out of a machine that's spinning, 900 RPMs.
That's kind of one of the reasons I've stayed. It's not mundane. Somebody's always asking you, can you do this? Can you do that? How can we do this? How can we do that?
That will take anywhere between 5 to 10 weeks, depending on what the size of the screw is, how intricate the geometry is, whether or not there's a lot of different variations in that geometry. Yeah, many people, when they see the end product, they think of it as like an auger, where you've got a round bar of steel and then you weld another piece of steel on that ends up being the flights. It's really quite the opposite in this case. We start off with a solid bar of steel, and then we cut all that steel out that is in between, that ends up being where the volume of the screw is, where the plastic is actually processed at.
While each part of this process has its own challenges, there is a general consensus on which ones are the most difficult.
To me, probably the most difficult one, job in the shop is the belt polisher. The reason is that these guys are taking different grits of belt. It's kind of like sanding a piece of wood that you've been working on to get a very smooth finish. And what these guys do is they get a piece of steel that's already been milled, already been welded. Probably 80% of the time and money will have been put into that screw at that point. So these guys are coming in, and these belt polishers that we have are all manual. So they're using touch, essentially, to keep these fine tolerances. So if somebody's having a bad day and they lean too hard on their belt polisher, they can really do a lot of damage, and it's a very expensive repair.
They've got a manual machine that they're holding, and they're bringing the tolerances within a few thousandths. By hand, they're doing that. Of course, they're measuring it with micrometer all along. But what a great skill that is, to be able to finish that screw and to get that kind of a finish on a screw and have it accurate all the way down the screw in terms of the tolerances on the screw. Welding is a very special skill because once again, the temperatures, you'll see that on our welder, and that's another CNC automated machine, but he's constantly checking the temperature with a melt pencil, because when you apply those carbides, it has to be within a very narrow window, or you either get a failure to bond of the carbide material or a cracking and a delamination of the material if it's not at the proper temperature. That's difficult.
Well, the most difficult part I would have to say is some of the thread work that I do. Some of the threads can be very large. If you get that wrong, then it's not an easy fix. The programming and making sure and double checking yourself and making sure that everything is correct in the program before you run it on the machine it's a little nerve-wracking at times. So it's very important to make sure that your program is right.
So we've got 2 people with great experience and background in designing of the screws, and the profile of that screw is completely dependent upon, because there's so many different plastics materials with so many different melting characteristics and physical properties, that the screw has to be properly designed for the material that it's processing.
Probably running the lathe. There's a lot of stuff that can go wrong, especially the CNC lathe. You're not doing anything. You put it on a program and you download the program and you hope everything goes well. You got a red and a green button, and if something looks wrong, you got to hit that red button fast enough. Oh yeah, I've shocked myself a couple times and burnt myself a couple times, but you just learn.
Yeah, the guys are very talented at what they do here.
Regardless of which part of the puzzle Glycon employees are working on, one thing is for sure, it is anything but routine.
It's not cookie cutter. They have to pay attention to detail. They have to be very in tune to what they're doing, and they do a very good job at it. They oftentimes don't get as much credit as probably a lot of people should give them for the type of work they do. It's a little bit removed, what they do from the actual plastics processing. So we like to point out what our customer products are, so that when they're going through the stores, or if they're in a car and they're looking at an instrument panel or a door panel, or if they're in a park and they see a bench or a picnic table that's made out of plastic, chances are those are one of our customers, so they actually get to put something with what it is, the work that they're doing here, so it's a little bit more meaningful for them.
They make kayaks. They blow mold kayaks in one shot. I'll be out there in a few weeks, and always fascinated to see this you can imagine how big the machine is that makes a kayak in one shot, but it's every time I see one of their products in the stores, and the company's called Lifetime, and if you go into the big box stores, all those tables you see, the big tables in folding tables and the chairs, that's all Lifetime products. And so that it's a great feeling to know that all of those products came out, the kayaks, the chairs, the tables, all came off of your screws. It feels good. I mean, there's an awful lot of satisfaction. I feel satisfied, and I ask myself that question every day. I say, are you doing something that's positive and that's contributing to society? And there's a big argument, and you've seen in this room some of the things that we've got about whether plastics is good for the environment. And there's no question that I've weighed that issue. I've looked into that issue. I've been around this for almost 40 years, and it is very positive, and it's the easiest material that there is to recycle. So I think that even though plastic gets a bad rap, body parts and artificial parts that are made out of plastic today have extended people's lives, and the world would be different if it wasn't for plastics.
I like a lot of the guys around here, and we all seem to have a good relationship. It's kind of enjoyable to come to work and like the people you're with.
For right now, being out on the floor and getting my hands dirty is fine with me, I enjoy what I do.
Our plans are to continue to grow the company, so there's a lot of growth potential out there. There's a lot of good signs in the economy.
My vision for the future is, continued growth and continued development in the capability to employ talented young people from not only Tecumseh but from Lenawee County.
Just do everything you can to the best of your ability. You're not going to get anywhere slacking, that's for sure. So, that's what I've always done.
So there you have it. From football in New Jersey, from egg-shaped rusted steel bars to polish, shining feed screws, Glycon is springing from visions to finished product. And they look to finish these screws for many years to come as a leader of what's made in Lenawee.